So for 5.3, what we're doing is essentially taking the information we've seen in 5.1 and 5.2 and going in the other direction. That is, instead of being given a value or a z-score and asked to find what area or probability gets associated to that, we'll be given areas or probabilities or percentiles and are asked to find the value that would be attached to them. Because we're not always going to have the information about a specific data point, or we're not always going to want to know what types of data points we're looking for. Or excuse me, we might not know what types of data points we're looking from. We may know something about overall behavior and want to see where that fits into the data set, or we may be looking for information about ranges of data points given amounts that we're trying to fit them to. We may say, want to look at a situation where your boss asks you to give 110% of your normal effort, and you want to know what 110% looks like in terms of hours, which may mean more than 24, but you may want to know what the associated amount is to that percentage. Or we may know that 60% of adults can see why kids love the taste of Cinnamon Toast Crunch.
It's got dandelions?
Dude!
And want to know precisely how many adults that would be. Again, we may have some information about a percentage, or we may want to know about the values attached to some percentage. And for that, we essentially are going to be reversing things. So if you think back to some of that mathematical stuff that you probably aren't happy to remember, at least some of you aren't, we have this idea of a thing called an inverse function, where an inverse function takes the opposite approach of what we're normally working with. So we have our normal CDF type thing that gives us information about an area given a value. So if we want to go from a value to an area or a probability if you prefer, that's what we use our CDFs or PDFs for. And what we're going to see here is how we can go in the other direction. We can use our inverse functions, in this case inverse normal, to find a value given an area. And to understand this, let's take one quick example. So for this example, we want to find the z-score that corresponds to a cumulative area of 0.3632. That is, we want to find what z-score has 36% of data to its left. It's important to understand here that when we use the phrasing cumulative area, we mean area up to. We mean it in the traditional sense of accumulation here, that we're going up to a point, not beyond, not between. So to do this, we can either do a little bit of exhaustive searching in the normal table to find the values that are closest to 0.3632 and then split out the row and column that it corresponds to, but I don't think this is a particularly efficient or intuitive process. So really, when I would have you do this sort of thing, I'd recommend learning how to do it in the calculator using the inverse normal function in there instead. Although it's worth bearing in mind that when we're dealing with this sort of thing, occasionally we'll end up getting values that are a bit off due to rounding, but we'll talk more about that as we're going. Anyway, to better understand what this type of thing looks like, just to be sure, we can also make sure we have a picture here where I waited a bit to show it because, well, the picture I have gives you the answer. But essentially what we are looking for is the amount to the left of some z-score that gives us 36% of the standard normal distribution, which here we can find if we go in the calculator using the inverse normal function of 0.3632 for the standard distribution to get a z-score of about negative 0.35. That is to say, the percent to the left of negative 0.35 as a z-score would be 36, roughly. And if you want to check this answer, if you want to check one of these that it works properly, you can just plug this sort of thing back into the normal CDF function and you should end up where you started because, again, we're working on a flow of information that goes in both directions. And next, we're going to see how we can do this with percentiles, where it's actually the exact same. It's just we talk about it in a slightly different context because, well, instead of looking at cumulative areas, we call things percentiles, but a percentile is just a cumulative area. Anyway, we'll see that next.